Welcome to lesson 16. In the last lesson, we started to take our mathematical ideas into the real world and give them a practical basis. I want to extend the ideas I introduced there, but I hope you had time to review them so we can effectively build on them. I want to put all our concepts together in this lesson and show you how to deal with what people usually find to be a difficult maths topic. Just pause the video and write down all the things you know about this new topic. This is the moment where students in class usually look confused. How can I write down what is in the new topic? I don't know what the topic is. What these students are overlooking is the fact that while they don't know some of the specific details, they do know the general structure those details will sit in. We have a view of all maths topics, even the ones we have never met. Let me illustrate. Our entry into the new topic will be via a scenario, which is a simple statement about what is going on. It gives us information about what is involved and how these things are related. This puts an emphasis on how our attention will transfer from one aspect to another. How an amount of the first item can be changed into an amount of the second item. Why would we want to do that? Because it often has useful applications in real life. What will you do with that awareness? You will feed it into our math structure. Remember, 3 types of maths. One focuses on how to change. The other focuses on how to calculate a missing value. And the other focuses on how to illustrate possibilities. So what do you expect to happen? Well, in type 1, you will need attention to details. How does the change happen? In type 2, we'll need to practice our technique, shift and reverse. Type 3, we'll need interpretation, so we can make the best choice of scale and axis labels. How would you describe that progress? Type 1 is easy. Type 2 is more difficult. Type 3 is sophisticated. But because you've done them, you should expect to be successful. You have already perfected the appropriate attributes. Now let's do this with a totally new focus so we can see how it all comes together in action. We need a scenario. Something easy to imagine. We will use the following. An ant is moving along and finds a half-buried piece of pipe blocking its way. So it walks over it. We can't get a much easier scenario than that. We have our scenario, why things happen. So we move to what can happen. Remember that we have to frame this in the context of a change. As we view the scene, we are looking for something that fits the general description. As this happens, then that happens. We can use the following. As the ant moves further over the pipe, it gets higher. So we can make the height our focus of interest. If we're interested in quantities, we must put a size on the diagram. So I'm putting a 1 to indicate the size of the pipe. That's the radius of the pipe. Now, as the ant moves further, it gets higher. So I need a measure of how far the ant has travelled. I'll use the angle A as a convenient measure of how far the ant has travelled. When A is small, the ant hasn't gone very far at all. As A gets bigger, the ant has travelled further. So I have two variables. How high is the ant as it moves around the pipe, generating an angle we can monitor. So what are we investigating? It is the height of the ant being related to the size of the angle I mentioned. The angle is a measure of the ant's travel. The height is the result of the pipe's shape changing the angle value as the ant moves across it. When abbreviated, height is a circular change of the angle, or height is a circular function of the angle. Now we know what we are working with, but what do we actually do? Well, it's what we always do. We complete our maths template. Type 1, examples. We generate some possibilities. Now I'm going to do type 3 next. That's the graph, because it illustrates all the possibilities. And then we'll finish with type 2, which is an equation-based question, finding an unknown. Finding the one possibility which matches circumstances we have described for us. So this diagram lets us generate our examples. We have the height of the ant and the angle it has generated as it's gone around the pipe. The ant obviously starts 0 height, 0 distance, and it will get to a height of 1 when the angle's 90 degrees. For part of the way around, we can use the appropriate angle and read off the appropriate height. For example, when the ant has generated an angle of 30 degrees, it's a third of the way around the pipe. It's actually halfway up the height of the pipe. And if we look at it when it's at 60 degrees, it seems to be nearly to the top. Its height is about 0.9 at a guess. So for type 1, here are our samples. Now, the more accurately you draw the diagram on the previous page, the more accurately you can state the height matching the angles. If we take our examples and transfer them to a set of axes, we can have a graph which shows how each of these angles in degrees generates a height. The radius of the pipe we said was 1 unit. So when the ant is at a height of 1, it's because it went around the pipe by 90 degrees. It's now at the top of the pipe before it starts to come down on the other side. So when we look at our overall template, type 1, samples, type 2, those samples have enabled us to draw a graph. Did you notice that I looked at the type 3 graph before the type 2 equation solving? I'm sure you did. That was because we want to use the summary held in the graph as an easy way of applying this function, process of change, and its inverse. We'll now make an equation to solve. The relationship here is the height is a modified form of the angle. When the relationship is abbreviated, this can be written as that. Notice I've kept the words. In mathematics, it would be abbreviated more dramatically. Now, this is called an equation if there's no practical context. And it's a formula when there is a practical context. And in mathematical terminology, a function is a process which changes a value. So here, our circle function generated by the presence of the pipe changes the angle representing the ant's movement into the height which corresponds to its movement at any stage. Anything developed from that formula can act as a suitable example of a type 2 calculation so long as there's an unknown. We can use 0.5 as a known height. What is the appropriate angle? So here we're asked to find the angle representing the ant's progress when the ant is halfway up the pipe, half the height of the pipe. So our calculation is 0.5 is the circle function of the missing angle. We use the inverse circle function to isolate the angle. Notice how it's written. We're only shifting a function, so we say inverse function. And the missing angle is 30. It would be 30 degrees. Now we've completed everything we need to know mathematically about that example, so we can update our summary. Samples give a height versus angle graph and allow us to solve a type 2 calculation based on that setting. Now have a look at the graph. When the height is 0.5, the graph tells us that the angle is 30. Remember, travelling this way on the graph means you are exploiting the inverse function. So 0.5 via the inverse function gives us the value 30 for the angle. Relate the problem to the overall summary of what can happen. And it turns out that that was one of the samples we had chosen at the very beginning. So just saying that again. 0.5 for the height requires the inverse circle function to isolate the angle. The inverse function is start at the result and go to the cause. Another example. Which angle leads to a height of 0.87 units? Generally speaking, height is the height function of the angle. When abbreviated, height and a capital letter for the height function. So these are the two variables, height and angle, and this is the process which links the two. So in this problem, 0.87 is the height function of some angle. So the calculation we need, the inverse of the height function, when applied to the 0.87, will show us the angle value. Or from the graph, or from a calculator, the inverse height for 0.87 is 60 degrees. Similar to before, simply different numbers. So note the use of abbreviations. Lowercase h represents the height in our example. Uppercase h represents the height function or process. And that's what makes the height from the appropriate input, being the angle. We'll come back to this and extend it later. For now, if you understand what we did here, you are officially good at maths. Combining it with the previous lesson, we have done some very sophisticated and quite difficult mathematics. But you should see an underlying structure that makes it easy. So this is how we should be seeing maths. Type 1, an investigation lets us see what can happen in terms of cause and effect, and this is where we see the measurements that are relevant to the relationship. Type 3 gives us understanding of how it works. It exposes patterns because it is an overview. And type 2 is an application part of maths. It clarifies situations where a specific case focuses our attention on details. Now you'll notice in this diagram I have not mentioned the ant example at all. That is because this diagram applies to all maths topics. I hope you've had an easy time through this topic. It is one that some people find difficult. But if you think about it, it will lock in very good progress. I'll see you again in the next lesson.